Okay, only 3 problems for today. We're going to be essentially doing the same thing that we did yesterday, except now that central angle is not going to be particularly as nice as that 30, 60, or 45. Remember, the very last thing that we talked about yesterday was that you don't have to draw the entire figure. Today is a great reason behind that. The first one, we are going to find the perimeter and area of a regular pentagon with a side length of 8. So instead of trying to draw out a regular pentagon, just draw out one side and know that there are 5 of them. Okay, so I have a side length of 8, which means that after I split it with my apothem, if all of this is 8, then half side is 4. When we have a pentagon to find this top angle, we're still going to do 360 divided by 2 times the number of sides. So this angle up here is 36 degrees. That tells us that we're going to have to use trig. So make sure that if you're using Desmos right now that everything is in degree mode. Also with your calculator, everything is in degree mode. So we need 2 things in order to find our area. Remember that our formula is 1/2 apothem times perimeter. So in this case, we have our perimeter. It is going to be 8 times 5, which is 40 meters. And now we need to find our apothem. Well, if we take a look here, I have my 36-degree angle, and in reference to that 36-degree angle, I have my opposite and my adjacent. So that tells me that I'm going to use my trig ratio of tangent to find my apothem. So I've got the tangent of my 36-degree angle is equal to the opposite 4 over the adjacent, which is my apothem. And to get that calculator ready, I'm going to do 4 divided by the tangent of 36. So I'm going to come over here, 4 divided by tangent 36, and I end up with an apothem of about 5.5. Now, since you guys are at home, I know not all of you guys have your TI calculators. If you have your TI calculator, I recommend that you store these values. And in order to store them, down on the bottom left-hand corner, right above the word on, is stow. And in this case, you could store it as an A for apothem. In this problem, it's not technically necessary because we have that value right there at the end, but it's always good to have. So now I need to do 1/2 times apothem times perimeter. I'm going to go ahead and do the 1/2 of the perimeter. So this is going to be A times 20. That way over here with Desmos, I can just go ahead and take my answer times 20 and end up with 110.1 meters squared. Now, if you go ahead and round it to 5.5, that's not going to hurt much. 5.5 times the 1/2 times the perimeter of 40 gets me 110 even. The way that we have this set up in your daily assignment is that there is a range of values, and I try to make that range big enough so that if you rounded it along the way, it's okay. But again, I would try to get into the habit of storing these values. You can continue to store values right on top of each other. So whenever you get to a different problem, if you choose to with your TI 84 or 83 or whatever you have, that's really the best practice, just so that you can get the most precise answer and not round until the very end. So here's where we don't want to try to draw a nonagon. It will fail, it will be horrible, and it will take you forever, and there's no reason to do it. So here is the side of our nonagon. It says it's inscribed in the circle with a radius of 5. So if the radius of the circle is 5, so is the radius of our nonagon. In a nonagon, this angle at the top will be 360 divided by 2 times 9, so 360 divided by 18, which gives me 20 degrees. I need the side length to find my perimeter, and I also need my apothem. So we're going to work 2 different sets to find each of those. Let's work with our side length first. So in order to find my side length, I've got my 20-degree angle up here at the top. Here is my side adjacent and my side opposite and my hypotenuse. So if I want to find the side length, we're first going to find the opposite side and then double it. So I have opposite and hypotenuse, which will get me sine. So the sine of my 20-degree angle is equal to the opposite O over the hypotenuse 5. So to get that calculator ready, we're going to do 5 times the sine of 20. 5 sine 20, which gives me about 1.7 ... And if I want to double that, let's do times 2. So one side length is about 3.4 ... And I'm going to go ahead and take that times 9 to get me my perimeter. Remember, this is a nonagon, so times 9 gives me a perimeter of about 30 point, I'm just going to say 78. So there's our perimeter. And now if we take and work through our, apothem, I have the adjacent and the hypotenuse, so that will be my cosine. So the cosine of 20 is equal to the adjacent A over the hypotenuse 5. So I'm going to have 5 times the cosine of 20. 5 cosine 20, which is about 4.70 if I round that to the nearest hundredth. And if that's my apothem, I'm going to take that times my perimeter. I'm just going to go ahead and use both rounded values. So 4.7 times my perimeter, 30.78. And then I want to take that and divide it by 2. 1/2 AP is going to be right around 72.3 units squared. And the last one, a wooden coaster has a regular octagon with 3 centimeter sides. So again, don't try to draw out an octagon. So this will be 1.5. If I have 3 centimeter sides for an octagon, 3 times 8 is 24 centimeters for my perimeter. So all I need to find now is my apothem. To find this top angle, I'm going to do 360 divided by 2 times 8. So 360 divided by 16 gives me an angle of 22.5 degrees. With that 22.5, I have the side adjacent and the side opposite. So to find my apothem, I am going to use tangent. The tangent of 22.5 is equal to the opposite, 1.5, over the adjacent A. So calculator ready, I'm going to do 1.5 divided by the tangent of 22.5. And that gets me an apothem of about 3.62. So I'm going to take that, and I'm just going to arrow over here so I can keep my exact answer, times my 24 for my perimeter, times that 0.5 for 1/2, and my 1/2 AP area will be about 43.5 centimeters squared. This is going to take some practice, but if you will keep organized and figure out what pieces you need. Notice we didn't really mess with the radius if we didn't have to. All you need is that perimeter and that apothem, and you can find the area for any of these regular polygons.